Hello kids, welcome to ICSE Chemistry Hub. Today I'll be starting with grade 9 chemistry of ICSE and I'll be dealing with the first chapter of grade 9 chemistry. So if you are new to my channel, kindly do like and subscribe my channel. Today, as I said, we'll be dealing with the first chapter of grade 9. And what is the name of the chapter, children? It is nothing but Language of Chemistry. This chapter you have already studied some part of it in your grade 7. Again, this chapter had come in grade 8, and because this concept is very important, ICSE has again repeated this chapter with a few more additions in grade 9. So we'll start with the basic thing. What is an element, children? We know an element is a pure substance. So the moment I tell what is an element, what's the first word that you should write? An element is always a pure substance. And where do you usually find elements, children? You usually find elements in the periodic table. Yes or no, children? This is where you find most of the elements. And if I ask you how many elements have been discovered till date, you know the number, it is 118 elements. Clear? So when I define an element, this is the basic unit of chemistry. Clear? So what is an element? An element is a pure substance. And what is it made up of? It is made up of one kind of particles. Or can I say they are made up of identical atoms. Okay? So this is a definition that you have learnt right from your lower classes. So what is an element, children? An element is a pure substance and it is always made up of one kind of atoms, or we can call them as particles. Either you can use the word atoms or you can use the word particle, or we can say that they are made up of identical atoms. For example, if I take a piece of zinc metal, okay, we call this as an element. Why do I call this as an element? Because it's a pure substance and it is made up of only and only one kind of atoms. When I say one kind of atoms, I mean here they are made up of only and only zinc atoms. There is nothing else that you will find in them. Okay, so they are made up of identical atoms, or we use the word that they are made up of the same kind of atoms. Clear? Okay. Now, whenever we show an element, you know where are the elements placed? The elements are placed in the periodic table. Most of the elements that are there, that is around 118 elements, they are indicated with the help of a symbol. So that means if you have a look at the periodic table, you will find that the whole name of the element will never be written. Yes, you represent it in the form of a symbol. So please remember, what is a symbol, children? It is a short form. Please, whatever I am marking, children, that are the keywords here. What is a symbol? A symbol is a short form, or it is an abbreviation of the name of the element. Clear? For example, if I have to write hydrogen, hydrogen is the first element of the periodic table. I can denote it in short, or I can call it as the abbreviated name of the element. What is the abbreviated name of the element, children? We know it is H. So please remember, what is a symbol? A symbol is a short form, or it is an abbreviation. It is an abbreviated form. For what do we use it? We represent an element with the help of it. So symbol is a short form, or it is an abbreviation of the name of the element. Now, what does the symbol that is there in the periodic table usually tell you? Does it tell me which element am I talking about? Or in other words, does it represent a specific element? For example, the moment I say H, I know here that the specific element that I'm talking about is nothing but hydrogen. The moment I write here He, I know that the specific element or the particular element that I'm talking about is nothing but helium. Okay? That is what is written here. H represents one atom of hydrogen. It also helps you to distinguish one element from the other. For example, if I see H as well as He, I know here H is the short form for hydrogen and I know He is the short form for helium. Clear, children? So what is a symbol? A symbol is a short form or it is an abbreviation name of the element. It will tell me which element I am talking about. For example, if I am talking about hydrogen, H means hydrogen, C means carbon. So it represents the specific element. It also helps you to distinguish. It also helps you to differentiate one element from the other. Clear, children? Okay. So the first scientist who made an attempt to make symbols was none other than John Dalton. This name you would have heard multiple times. He was the same scientist who gave the atomic theory. If you have learnt about Dalton's atomic theory in your grade 7 and 8, that was proposed by the same scientist, that is John Dalton. So John Dalton was the first scientist who made an attempt to make the symbols for different elements that he had known that time. But the symbols that he gave during that time were called as figurative symbols. Now, what is the meaning of the word figurative symbols, children? As you can see in this diagram, he represented the element. He said the short form of the element can be in the form of figures. Okay, he drew those figures and he called these symbols as figurative symbols. So if they ask you in the exam, name the scientist who proposed figurative symbols. Who is the scientist, children? It is none other than John Dalton. So these are the figurative symbols that you can see in the PPT for the different elements that he had known by that time. For example, if you see, oxygen is denoted by a circle. Hydrogen, he drew the same circle, but in the center he drew a dot. So oxygen is a simple circle, hydrogen is a circle with a dot, carbon is a circle, but it is a shaded one. Okay, so this is how figurative symbols look like. Okay, now there were two problems that were there with this figurative symbols. Okay, the reason why this figurative symbols was discarded after a certain period of time was it was very, very time consuming. So what was the first drawback of this method, children? The first drawback was this method was actually time consuming. Don't you think so? Instead of drawing a circle and then putting a dot for hydrogen, it is much more easier for me to instead write hydrogen. Clear? So the first drawback of figurative symbol was that it was a very, very time consuming process. Clear? The second drawback of this method was it was actually becoming very, very difficult to remember all these figurative symbols. Agreed, for one or two elements I can remember. But for these many elements, there were some 10 to 20 elements that were discovered during that time. So it was becoming very, very difficult to remember these figurative symbols. And because of these two drawbacks, this figurative symbols did not work out for long. Okay, so just remember who is the scientist who gave figurative symbols. It is John Dalton. He represented the name of the element. The short form was using figures. Now, why was this system discarded? One, because it was very, very time consuming. That was the first reason why it did not go on for long. The second reason was it was very, very difficult to remember all these symbols. So slowly they discarded this figurative symbols. The symbols or the short forms that we use today was given by a Swedish chemist named as Berzelius. If you just remember this name, that is enough. So who is the scientist that proposed the symbols that we use today, the chemical symbols that we use today, was given by a scientist called as Berzelius. He made it very, very simple. He said, let us not use any complicated figures for symbols and formulas. We will just be using, he said, Let us just use one or two letters. Clear? So no need to complicate it too much. Just make it simple by using symbols, and the symbols would be indicated by only letters. Now he said that they will be taking the first letter of the element. For example, if it is oxygen, what is the first letter of oxygen, children? O. And he said, how should that O be written? O should be a capital letter. Similarly for nitrogen. If I have to put the symbol for nitrogen, we will take the first letter. What's the first letter? The first letter is nitrogen, is N. And how will we write N, children? It should be a capital letter. Hydrogen, again, the first letter is H and H should be a capital letter. Okay. So he said that whenever we are using symbols, we will be using the first letter and we will be making the first letter as capital. But very soon they came up with the next difficulty. They found out that there were certain elements whose first letter was getting repeated. Okay. So whenever this happened, Berzelius said, let's make it simpler. We will take the first two letters of element. So he made the first letter as a capital letter. For example, if we take helium, first letter is a capital letter and the second letter will be a small letter. So first letter should be capital, second letter should be small. Similarly for the third element, which is the third element of the periodic table, lithium. The symbol is, the short form for lithium is Li. First letter should be capital, second letter should be small. So whenever you are writing the symbols, children, if you are taking only the first alphabet, the first alphabet should be a capital letter and you should denote it with a capital symbol. Okay. Helium, if you are taking the first two letters, the first alphabet should be a capital letter and the second alphabet should be a small letter. Similarly for beryllium, okay, we are taking the first two letters. What is the first letter, children? B, which should be a capital letter and the second letter should be a small letter. Okay, so this is how Berzelius put the first two rules. That take the capital letter, first letter, make it capital. Take the first two letters. If you are taking the first two letters, first letter should be a capital letter, second letter should be a small letter. Even after that, if the element's name or symbol is getting repeated, then Berzelius said that we will be taking Latin names. Okay, why Latin? Because this is the language that most of the scientists follow. Okay, they either use Greek or they use Latin names. So Berzelius said that whenever we are making symbols, we will be going ahead with which kind of names, children? We will be remembering the Latin names. We will be taking the Latin names. Now, these are the few Latin names that you need to remember. Okay. So, the first element is copper. It is taken from the Latin name. What is the Latin name for copper, children? It is cuprum. Please remember this as this can be asked for your exam. So, the Latin name of copper is cuprum. Now, there will be a confusion between gold and silver. Okay. Please remember the Latin name of gold is aurum. So, what is the symbol of gold, children? Au. Gold is aurum. Silver is, the Latin name of silver is argentum. Okay. So, what is the symbol for argentum that is taken? Ag. Okay. So, remember gold is Au. Silver is argentum, that is Ag. Okay. Now, lead. If you can tell me where lead is used, it is usually used in pipes or it is usually used in, we call it as plumbing things. Okay. So, because it is used in plumbing, what is the Latin name of it? It is called as plumbum. We take P and we take B. So, the symbol of plumbum or lead becomes Pb. Okay. Mercury that you use in thermometers is called as hydragyrum. Okay. So, please remember the Latin name. The Latin name of mercury is hydragyrum. What is the symbol? It is capital H and small g. Potassium is called as kalium. So the symbol of potassium is K. Sodium, the Latin name of sodium is natrium. What is the symbol, children? It is Na. Okay. Tin, the Latin name of tin is tannum. We use Sn. So these are the Latin names that you need to remember. We'll quickly once again go through the Latin names. Copper is called as cuprum. What will be the symbol? Cu. Gold is aurum. The symbol is Au. Lead, as I told you, we'll use it in pipes. So we call it as plumbum. What is the symbol? P and a B. Mercury is called as hydrogyrum. It is Hg. This is the symbol of mercury. Potassium is called as kalium. What is the symbol for kalium? K. Silver is called as argentum. Ag. Sodium is called as natrium. Tin is called as tannum. What is the symbol of tin, children? It is Sn. Okay. So it is better that from your 9th standard, you start by hearting the first 20 elements that are there of the periodic table. Okay. Along with the name and the symbol. So we know hydrogen is the first element. What will be the symbol? H. Helium, He. Lithium, Li. Beryllium, Be. Boron will be B. Similarly, try to by heart and learn the first 20 elements of the periodic table. Okay. So we are done with symbols, children. Okay. What is a symbol? A symbol is a short form or it is an abbreviated name of the element. Clear? Next, we are going ahead. Now, whenever you write the symbol, have you seen there will be some number that will be accompanying the symbol? For example, if I take helium, the valency is 0. Okay. So these numbers that I write, Li is again +1. All these numbers that I write is nothing but valency. Okay. Now there is an old definition of valency and then you have a new definition of valency. Okay. So you have to remember both the definitions, but usually we'll be following the new definition. Now what is valency, children? Just see, whenever I wrote valency, I said it is always a number. Okay. So what is valency? It is always a number. But in old definition, the old scientists said it is the number of hydrogen atoms which can combine, or it is the number of hydrogen atoms which are attached with any particular element. Okay, but please do remember this is the old definition of valency. So what is the old definition of valency? As I told you, valency will always be a number. Okay, it is the number of hydrogen atoms. Now this hydrogen is always taken as a reference in chemistry. Okay, so it is in olden definition, they say that it was the number of hydrogen atoms which are combined with any particular element. It can be X, it can be Y, it can be chlorine, it can be oxygen, it can be nitrogen, it can be anything. Okay. So come ahead with the definition once again, children. It is the number of hydrogen atoms which can combine with any particular element while forming a compound. To make the definition clear, let us go ahead with the examples. Okay. The first example here is hydrogen chloride. Now, what is the definition? What is the old definition of valency, children? It is the number of hydrogen atoms, okay, which are combined with any particular element. Which is that any particular element here? It is chlorine, okay. So, can you tell me, when you look at the formula of hydrogen chloride, how many hydrogens have combined? The number of hydrogen atoms which have combined with any particular element. In this case, that any particular element is chlorine. So what will be the valency of chlorine, children? It will be 1. Okay. And always remember this, children. Metal, the moment you see a metal, close your eyes and put a positive sign. The moment you see a non-metal, close your eyes and put a minus sign. So please remember, metals will always get a positive sign. Non-metals will always get a negative sign. I hope this is clear to you. Okay. So now come back to the definition. What is valency? It is the number of hydrogen atoms. So when I am taking HCl, how many number of hydrogen atoms have combined with chlorine? From the formula itself, it is clear. It is only one hydrogen atom that has combined here with that chlorine. Okay. And we know is chlorine a metal or a non-metal? We know it is a halogen. So it is nothing but a non-metal. And I have told you, metals always get a plus sign and non-metals always get a minus sign. So can you tell me what will be the valency of chlorine? The valency of chlorine will be -1. Let us take one more example. You know what the formula of water is. What is the formula of water, children? Formula of water is H2O. Come ahead with the definition. It is the number of hydrogen atoms, clear, which can combine with any particular element. Okay, so in this formula of H2O, how many atoms of hydrogen have combined? 2 atoms of hydrogen have combined with any particular element. What is the element here? The element is nothing other than oxygen. So what will be the valency of oxygen, children, here? 2. Why 2? Because the number of hydrogen atoms that are combined are 2. And we know oxygen is again a non-metal. So if oxygen is a non-metal, what will be the valency of oxygen? It will be -2. Okay. Let's take one more example. You must have heard about this gas. Which is this gas, children? It is nothing but ammonia. Can I also write it as NHHH? Come to the definition. What is the definition? It is the number of hydrogen atoms. Can you tell me how many hydrogen atoms have combined with any particular element? What is that any particular element here? It is nitrogen. How many hydrogens have combined here? It is 3. And we know nitrogen is a non-metal. So what is the valency of nitrogen here? It will be -3. Clear? Now take one more example. We call this element as CH4. What is CH4? It is a hydrocarbon and the name of this hydrocarbon is methane. I can draw that structure as CH, H. How many H's are there, children? 4. Okay. And we know it is a number of hydrogen atoms which are combined with any particular element. Which is that any particular element here? It is carbon. And how many hydrogen atoms have combined here? It is 4. But it will be -4. Why am I calling it as -4? We know carbon is a non-metal. So whenever you have a non-metal, please remember, non-metals will always get a negative sign. So what is the valency of carbon? The valency of carbon will be -4. Okay. So what is the definition of old definition of valency? It is the number of hydrogen atoms which can combine with any particular element. Okay. And as I told you, valency of all metals is considered to be positive. Valency of all non-metals is considered to be negative. Okay. Now, there are 3 types of elements. There are, depending on the number or the valency that they have, we can call them as monovalent. What is the meaning of the word mono? Mono means 1. Okay. So either it can have +1 or it can have -1. So any element that is having +1 or -1 valency will be called as a monovalent element. Clear? Divalent. Anything, di means 2. Anything or any element which has a valency of +2, like Mg+2, Zn+2, or even if it has got -2. Is this a divalent element? Yes or no? Because it is S -2. Clear? So this is nothing but divalent element. What are divalent elements, children? If they are having a valency of +2, either it should be +2 or -2. What are trivalent elements? Either it should have +3 or it should have -3. Okay. So mono means 1, di means 2, tri means 3. Suppose in the exam they ask you what is tetravalent. Will you be able to tell me what is tetravalent? Tetra means 4. Okay. So anything that is having minus 4 or plus 4 valency. And please remember, many times it is even asked in your 10th standard board exam. A tetravalent element. So which is a tetravalent element that you have to remember? Please remember, it is carbon. Carbon is a tetravalent element. When I say tetravalent, it means it has a valency of 4. Okay. Now please remember, valency of any noble gas that you take. What are noble gases, children? Can you tell me the examples of noble gases? Helium, neon, argon, krypton, xenon, radon. Any of these noble gases. The moment you hear it's a noble gas, please remember the valency of all the noble gases will be taken as 0. They do not have any valency. Okay. Now, before we go ahead, I want you to understand what is the new definition of valency. We have already dealt with the old definition. We will now be dealing with a new definition of valency. What is a new definition? I have always told you valency is a number. Okay. For example, if I say valency of sodium is Na plus 1, it is a number. If I say the valency of magnesium is plus 2, it is again a number. I just now gave you an example of a tetravalent element, which is carbon. So it is always a number. Okay. But the old definition said it is the number of, it was the number of hydrogen atoms. Clear? But the new definition says it is the number of electrons. Did you understand the difference between the old definition and the new definition? Old definition says it is the number of hydrogen atom, whereas the new definition says it is the number of electrons that is either given or that is taken. So look at the words that is written. That is either donated or that is accepted so as to achieve all the elements in the periodic table want to achieve stable electronic configuration. Now, who has that stable electronic configuration? It is nothing but noble gases. You know this, okay? These are the only elements which are stable in the periodic table. All the other elements are very, very reactive. They keep on jumping like a popcorn. They want to become stable, okay? So, what is a new definition of valency? And this is the definition that will mainly be asked in your grade 9 and grade 10. What is valency, children? It is the number of electrons. Okay, so please remember this. It is the number of electrons that are either given away, donated, okay, or taken. What will we call as taken as? We call it as accepted. Now, why do they give? Why do they take? Why do they do all this business? Because they want to become like noble gases. Okay. So once again, let's revise the definition of valency. The new definition says it's the number of electrons donated or accepted. Clear? Now, why do they donate? Why do they accept? Because they want to become like noble gases. Clear? Now, you must have read, I just now told you, metals always have plus valency. Okay. Now, why do they have a plus valency? Because they always donate. They like to give. So, in real life also, when you give, when you donate something, you become a positive person. Okay. So, whenever you donate or whenever you give something, okay, you become a positive person. The same thing happens with metals. Metals are always donors. What's the meaning of the word donors, children? They always like giving to someone else. Okay, so when they give, they always get a positive sign. Clear? Come to non-metals. Whenever we talk about non-metals are a little selfish. They always like to take. What do they like to take? They always like to take electrons. Clear? Or they would like to accept electrons. These are the two words that we can use. Okay, they always take, they always accept. So always when you keep on asking something from the other, you become a what kind of a person? You become a negative person. Clear? So the same thing happens here. Metals, because they are donors, they get a positive sign. Whereas non-metals, because they always keep on taking. When you take something from someone, you get a negative charge. So, but why do they give? Why do they take? They do all of this because they want to become like noble gas. They want to have stable electronic configuration of the nearest noble gas. Okay. So, I had told you valency of all the noble gases, be it helium, be it argon, helium, neon, any noble gas that you take. What is the valency of any of these noble gases? It is 0. Okay, now why do they say it is 0? Please remember these 3 words. They do not donate what? Electrons. They do not share electrons. They do not accept electrons. Because of these 3 reasons, they have a valency of 0. Now, why do they give? Why do they take? I had told you they want to become like noble gases. What is special about noble gases? Either they have completed their duplet. Okay. For example, if you look at helium, helium is very, very stable. Why do we call it is stable? Because it has completed its duplet. Yes or no? Okay. It has 2 electrons in its outermost shell. So it is stable. Okay. So it does not, what did I tell you children? Helium does not donate electron. It does not take electron, or what is the other word we can write? It does not accept electron. And third thing, it does not share electron. Why it does not do all these 3 things? Because it has already attained its duplet. It is already a noble gas, and noble gases are highly, highly stable. Okay. Similarly, for all the other noble gases, they would like to complete their octet. Okay, can you see here? 1, 2, I'll just number them. 1, 2, 3, 4, 5, 6, 7, 8. In their valence shell, they already have 8 electrons. We call this arrangement as an octet. Okay, so all the other elements are trying for an octet. But what about argon? Argon has already completed 8 electrons in its outermost shell. Okay, so that is the reason why the valency of any of the noble gases that you take. For example, if it is neon, 1, 2, 3, 4, 5, 6th electron, 7th electron, 8th electron. It has already completed its octet. Okay. So it is already completed either its duplet or they have completed their octet. So that is the reason why they don't want to mix with anyone. They like to be alone. And that is the reason why their valency is 0. What are the 3 words? If they ask you this in the exam, that why the valency is 0 for noble gases. Remember 3 words. They do not donate. Second thing, they do not accept. And the third thing, they do not share the electrons. Okay, so what are the 3 words? They do not donate, they do not accept, they do not share their electrons. All the other elements in the periodic table, except the noble gases, are very, very reactive. What do I mean by the word reactive? They will do all the 3 things that were discussed. They will donate electrons. Yes. They will accept electrons. And they will also share their electrons. All the 3 things will be done by all the other elements in the periodic table. Okay. Now, why do they do this? Why do they donate? Why do they accept? Why do they go and beg from all the other elements? Why do they decide to share? They do all this because they want to attain their octet. Am I clear? Now, what is the meaning of the word octet? Octet means they should have 8 electrons in their outermost shell. So all the elements which do not have that 8 electrons, they will be very, very reactive. Okay. Now I will stop with one question that was asked in one of the board papers. And the question is this. Noble gases have their octet dash. What will be the answer, children? For all the noble gases, their octet is completed. Whereas for all the other elements in the periodic table, all the other elements, the octet. What is the meaning of the word octet? Octet means 8 electrons in the outermost shell will be incomplete. Okay. If the element is reactive, that means the octet is incomplete. And that is the reason why they will do all the 3 things. They will donate, they will share, and they will accept. So the moment you hear that the element is reactive, remember its octet will be incomplete. Am I clear till here, children? So I hope the definition of element and the old and the new definition of valency are clear to you. Okay. Hope you have liked this video, children. Please keep learning. Please keep revising. And also do stay tuned for more such videos. Please do like and subscribe my channel.